Okay, welcome to AA2.3. We're finding inverses by graphing. It's a pretty quick process, so hopefully it won't take us too long. You don't need the investigation piece. All right, so the basic steps here, if you need to, make an XY table and graph the points. Make a second table and switch all those X and Y values. I'll show you what I mean by that in a moment. Graph the points from the new table, and if possible, write the new equation. So we move over to, we've got g of x equals negative 2x plus 6. G of x here is simply another name for an equation. F of x is the same thing as y. G of x is also the same thing as y. It's just a different equation. So I wrote f negative 1 of x. That should be a g. So what I'm going to start with is making this table. So you can do this. Several people may know that you have the y-intercept of 6, slope of negative 2, but if you're ever uncertain about how to graph anything, you can always pick some points for x. Negative 2, negative 1, 0, 1, and 2 are often a good bet, and start plugging numbers in. So negative 2 times this negative 2 right there, plus 6 gives us positive 4 plus 6, which gives us 10. So we put that value for the y. Move on to the next one, negative 1. So we've got negative 2 from the equation times negative 1 for our x value plus 6. 2 plus 6 equals 8. Plug that in for y. Negative 2 times 0 plus 6. It's just 6 because anything times 0 is nothing, or is 0. And then I can continue to do that, or I can recognize that now that I have more than 2 numbers, I got a pattern going. This is going down by 2 every time. So that's going to go 4 and 2. Then I'm going to graph all those points. And I'm going to go ahead and do my original. This is my g of x. I'm going to do my original in blue. So negative 2, 10 starts up here. Negative 1, 8. 0, 6. 1, 4. 2, 2. And if I note this is going down 2 and over 1 every time. So I'm going to keep going down 2 and over 1. And I'm just going to keep doing that because I don't have a ruler. And I want it to be as straight as possible. So there's my original function. Now, what I'm going to do is take all my x values, and I'm going to put them in the y column. And I'm going to erase those so this doesn't get too messy. So I'm going to do negative 2, negative 1, 0, 1, and 2. Then I'm going to take all of my y values, 10, 8, 6, 4, 2, and I'm going to put them in the x position. And again, get rid of that so it doesn't get too messy. So 10, 8, 6, 4, and 2. Then I'm going to take each of those points, 10, negative 2, and I'm going to graph it. Whoops. So 10, negative 2, 8, negative 1, 6, 0, 4, 1, 2, 2. And then if I can tell what's happening here, I'm going back 2 and up 1, back 2 and up 1. And I'm going to keep that pattern going back 2, up 1, back 2, up 1. So I should have very similar patterns here. And one thing that you should note about all of these inverses in their graphs is if you put them on the same graph, they should be symmetric over the, like note right here that they're meeting at the point 2, 2. Now, not all inverses are going to meet where y equals x, but that's where the values are the same. They won't necessarily meet at those spots, but they will always be symmetric across that line, that y equals x line. So if well, let me turn it. So if I turn this, oh, look, it will. What happens is this part right here reflects, hopefully you remember that from geometry, over there, and that reflects over there. So these are symmetric across that x equals y or y equals x axis. So I don't know what parts it picks, what doesn't. So that's our first one. Want to move on to the second one. I forgot. The last little bit of this is figuring out the equation, if you can. And with lines, you should be able to, by knowing that you have an intercept here of 3, and you're going down 1 and over 2. So our inverse function is g negative 1 of x. That's our inverse notation. Is negative 1/2 x plus 3. So now we'll go to the next one. And this is going to be the last thing we're going to do. This particular one, x minus 2 squared minus 5. Keep in mind, this is going to be a parabola. Parabolas have that a times x minus h, not 2, squared plus k. If you can tell what our vertex is by that, by the hk position, if you can't, go back to 1.3. This is 2, negative 5. And given that the a value here is 1, we're going to have a particular pattern. If you don't note that pattern, then you can start with your vertex, 2, negative 5, and go 2 above it and 2 below it. So 2, 1, 0, and then 3 and 4 on the other side. So if I decide to go for plugging in the numbers, just like I did with the line, then I can just put in x, sorry, not x, 0 minus 2 squared minus 5, which gives me negative 2 squared minus 5, which is 4 minus 5, which is negative 1. So I can do that through the entire process if I want to. The other thing, and this is what I'm going to do, is in blue, I'm going to go ahead and graph my vertex at 2, negative 5. And then I'm going to go out 1 and up 1, because I know my a value is 1. And then the pattern, when a is 1, is 1, 3, 5. So out 1 and up 3, out 1 and up 5. And if I want to be really precise, out 1 and up 7, which I'm going to run out of space for, it'll be up here. So that's my parabola. So what I can do then is just fill in my table by finding those points. 1, negative 4. 3 is also negative 4, and then 4 is negative 1. And then flip, just like I did before, flip my, take my y, put it in the x position. So negative 1, negative 4, negative 5. One thing I want you to notice here is that none of the negatives are moving who they stay with. So what I mean by that is 1 is negative, it stays with that 1. Some people have a tendency to switch those, which causes them problems, and then their inverses don't fit. So then I want to graph those points. I'm going to do that in red. Negative 1, 0, negative 4, 1. Negative 5, 2, negative 4, 3, and then negative 1, 4. So then what, maybe it will let me do this. We'll see. Hang on. Oh, look at that. What you might notice is that we have this sideways parabola, and we can keep putting in the 1, 3, 5, putting in those extra points there so that we're basically drawing a sideways parabola. And then let's see if it'll let me turn it around. Oh, look at that, it did. How about that? Okay, so then what I want to check is that symmetric across that y equals x line? And that is a very not straight line. And yes, it is. If you look at how this should have gone, that would have crossed a little bit better there. And what we can consider, we don't really know some of these graph names. This one happens to be, if we're giving it a inverse equation, we haven't done parent graphs yet, so I wouldn't necessarily expect you to know this, but the inverse of squaring is square rooting. So this is going to be x plus 5, square root of x plus 5, and then plus 2. That would be expecting a bit much of you guys to know that. But the linear ones you can figure out relatively easily. And that's pretty much it. Switch x and y, make sure that you're symmetric across that y equals x line, and you're good to go. All right, that's it for graphing inverses, and we'll move on to algebraic in 2.4. Have a great day.